Solving the quadratic means solve for x, correct? How many solutions do quadratics have? 2, since the highest degree is 2. So we first get set equal to 0, so we have our 2x squared plus 2x minus 4 equals 0. Now we can solve by factoring your quadratic formula. If we factor right now, it's going to be long factoring. So if you notice, shouldn't I just pull out a 2 from the get-go? Leaving me with x squared plus x minus 2. Now doesn't that factor? Well, multiplies to be negative 2 and adds up to be 1. Good. And then, so our final factor would be x2 times x minus 1 times x plus 2 equals 0. Now, I have a lot of people in this class still getting this wrong, so everybody please, once again, listen. 2 does not have a variable in this problem. So 2 is not going to be affected in the solution. Do you see what I'm saying? You said that equal to 0, 2 equals 0, not true. Not a solution, right? Then, all right here. So our solution is x equals 1 and x equals negative 2. We should only have 2 solutions. If you have 3 listed out, you should say to yourself, what's going on? I only have degree 2. I should only have 2 solutions. Okay, awesome. Then also don't forget, just because you factored it doesn't mean you've solved it. You've literally just taken an apple and squished it down. Now do something with it. Does that make sense? Okay, cool. All right. If I said you factor, though, we would have stopped right here. Okay, let's go on. So, first of all, okay, if I say to you, find all the real square roots, that means because of the word all, we need plus and minuses. So, the square root of 36 is plus and minus 6. The square root of negative 100, we said real, so none. Right? Then right here it says simplify the following and use absolute values when needed. So if we were simplifying this, we're pulling out groups of 3. 9 divided by 3 is 3, so it pulled out evenly. 12 divided by 3 is 4. Then you would check. Oh, that's a B. I did that last hour too. So we have our a cubed b to the 4th. You shouldn't be taking notes right now. You should just be watching. It's all review. Okay, so everybody, even roots? No, we don't need absolute values. Okay, moving on. Look at number 6. The square root of 16b squared. What does that simplify to be? 4b. Even root? Odd exponent? So we need absolute values. We don't put absolute values around 4. 4 is positive. Good to go. It only goes around variables. Okay, look at this one. Number 7. It's not on your paper though. So if we were doing the cube root, remember you can have a negative. It'll just be a negative answer. The cube root of 343, I think it's 27 times 3. No. 7 and 49, good point, and then 7 and 7. Is everybody with me? So we pull out a 7, we pull out a negative, so negative 7, and then cube root of a cubed. 8, so there's no radical left. We pulled everything out. Even root? Nope. So we don't need absolute values. Okay, do not let fractions throw you off, you guys. If you have a fraction, split it up, the 4th root of 1 over the 4th root of 16. What's the 4th root of 1? 4th root of 16. 2. Okay, story problems. So we really cannot say, oh, I can't do story problems because we're in an advanced math class and we are going to do story problems. When people say that and we're dealing with something like this, I get really sad because it's literally asking you to do the easiest things ever. So it says, the voltage V of an audio system speaker can be represented by this formula. On your ACTs, there are always problems where they give you a random formula. They tell you what the variables mean. They give you some of the variables and expect you to then find the one variable they didn't give you. So it's very just algebra oriented. All right, so here's the here is the equation. It says where P is the power and V was voltage. So you say to yourself, that's voltage and this is power in the formula. Okay, good to know. It says, an engineer wants to design a speaker with 400 watts of power. What do you think that is then? What variable? P. It says what will be the voltage. So in this one, we're trying to find V. So V is equal to 4 square roots of 400. The square root of 400 is 20. 20 times 4 is 80. Our voltage is 80. Was that hard? No. So don't always just assume that we can't do it, which a lot of you in this class are really good at not assuming. Okay, good. Moving on. Remember, when multiplying radicals, either the radical has to be the same or the base has to be the same. So look right here. Wouldn't this be the square root of 3 times 4 under the same radical? Which is, we'd break it down, so we'd pull out a 2. 2 root 3. Right here, wouldn't we say this is 3 to the, well, it's not the same radical, so we're going to have to solve this by rational exponents instead, right? So remember, roots go on bottom, power goes on top. So this would be 2 over 1, wouldn't it? Times 3, root goes on bottom, power goes on top. When you multiply the same base, you add the exponents. Do you do 3 times 3 as well and put 9? No, that's double dipping. We keep the base the same base. So guys, 1/2 plus 2/3. Yep. So we have 3 to the 5, 6. Now here is the general rule of thumb. If it starts as a radical, your final answer would need to be written as a radical. So we'd say the 6th root of 3 to the 5th. Done. Are we good? This is all stuff we learned last time. Okay. Now, why can I actually multiply these things together, even though it's breaking all the rules? Yes. Okay, good point. Yes, you're right. That is one reason. Can't we simplify the square root of 16? So, yeah, good point. So this would be 4. So that would be 4 times cube root of 2. Agreed? Okay, cool. All right, when adding or subtracting radicals, it's way more picky. The radical and what's underneath have to be the same. 2 square roots of 3 plus 4 square roots of 3 is how many square roots of 3? 6 square roots of 3. 2 root 3s minus 4 root 3s is how many root 3s? Negative 2 root 3s. Is this all ding and bells for you? Oh, we already know how to do all this. Yeah, you're right. Okay, here's where we were cut off last time. It's rationalizing denominator. So everybody, you have your 5-1 out. Okay, I want you to look at this problem. We've rationalized denominators before of this caliber. So looking at 2 divided by root 3, the first thing you should check is, can my radical simplify? Root 3 can't. Now, we can't have a radical on bottom. It's just not considered simplified. So we would multiply by what to rationalize? Yep, square root of 3. You do that to the bottom. You've got to do it to the top so that you're only multiplying by 1 technically. So on top, we get 2 root 3. And on bottom, technically, we get root 9. Now, what I want you to really think about is, technically, yes, we get root 9. But instead, couldn't I think of that as the square root of 3 squared? 3 times 3? So now look how much easier that is. Root cancels out with power. What was left on bottom? 3. It would have got us the same answer to call it square root of 9. It's fine, but I'm just making a point here. So our answer would be 2 root 3 over 3. We can't divide under radical with what's not, so that would be our answer. Okay, look at this one. A lot of people will see this and they'll just rationalize, but don't. If it simplifies, do that first. So what's the answer? 3/2. We didn't need to rationalize. If we did, we would then rationalize, we then have to simplify, and then it would simplify to be 3/2 anyway. All right, now we're not always going to have square roots when rationalizing denominators. So from here on out, we have to be able to rationalize any type of denominator. That brings me to 45. Okay. On number 45, we have a cube root. So far, we've only rationalized with square roots. Now think about it. For a square root, we need something to be squared so that root cancels out with power. So with a cube root, we need something to be cubed so that root can cancel out with power. Does everybody agree? So what we're going to want to do here is say, I'm going to break down 45 and see if I can pull anything out. If so, I'm going to pull it out. If not, then I'm going to use those things to get 3 of them. So let's look here. 45 is 9 and 5. 9 is 3 and 3. Now look, we've got to pull out groups of 3 so it doesn't simplify. Well, here's what's going to be useful. Instead of writing it as 45, let's write it as 3 times 3 times 5. So everybody rewrite the problem. This is 3 over the cube root of 3 times 5. We've not rationalized, we've not done anything, it's the same problem. But why is this useful? Because now we can rationalize by the least amount possible. So we're going to say, okay, we have 2 3s. How many 3s do we need to make it 3 cubed? We need 3 total, correct? So how many more, when I go to rationalize my denominator, how many more 3s am I going to need? There's 2 already. We need 1 more 3. Okay, good. Now we have 1 5. We need it to be 5 cubed. So how many more 5s? 2 more. So if you do that to the bottom, you've got to do it to the top. So we have a 3 times 5 times 5. Now if you look at the top, we have a 3 on the outside, so that's still going to be there. And if you think about it, while we have it broke apart, let's see if we can pull out any groups of 3. We have 1 3 and 2 5s, so no. So 5 times 5 is 25 times 3 is 75. And we already know the cube root of 75 won't simplify since we were looking at it right here. Now on bottom, if you think about it, what we have right now is this. The cube root 1, 2, 3 3s. So we have a 3 cubed times 1, 2, 3 5s times 5 cubed. That was what we wanted. Because there's a multiplication sign, it's not breaking the forbidden rule to say root cancels out with power. So what's on bottom? 15. That took care of the radical for us. So we have on top 3 cube roots of 75, and on bottom we have a 15. We're not quite done, but does everybody see how the rationalization took place? And it fixed the problem. There's not a radical in bottom. Now because we know we can divide across a multiplication sign, we can divide out 3 and 15. That simplifies to be 1 over 5. So final answer would be cube root of 75 all over 5. We would never divide something under a radical with something that's not. So we're done. Let's do another one. It just takes a couple more of practice. Okay, look at 46. So we have 3 over the 4th root of 135. We're going to need it to be to the 4th power to have root cancel out with power. Let's break down 35 though so that we can do the least amount possible. 135 is what times what? And then 27 goes down to 9 and 3, and 9 goes down into 3 times 3. So let's rewrite what we're looking at here. We're looking at 3 over the 4th root of 3 times 3 times 3 times 5. We haven't done anything to it yet. Now we can rationalize. So because it's to the 4th power, we're going to need them to be to the, since it's to the 4th root, we're going to need these to be to the 4th power. We have 3 3s. How many more do we need? 1. Good. We have 1 5. How many more 5s? Good. And now we've done the least amount possible. The rationalization with the least amount. You've got to do the same thing to the top as well. Okay, so now we already have a 3 on the outside. So we have a 3, a 4th root. This is for the top. Look, nothing pulled out. 3 5s and a 3. 5 times 5 times 5 times 3 is 375, I believe. And then on bottom, and I'm going to go out over here and do what the bottom is so I can just put my final answer here. On bottom, don't I have the 4th root of 3 to the 4th times 5 to the 4th? So root cancels out power again. That was our goal. So 15 was on bottom. So now once again, because it's multiplication, connecting that stuff together, we can divide. 1 over 5. There's our answer. Okay. Do you guys think you can do number 47 by yourself? Okay, try. For people who need to see it, I'm going to do it for my video. So 25 is the same thing as 5 times 5. So then when rationalizing, we need 2 more 5s, don't we? Okay, cool. So now on top we have 9 4th roots of 25. And on bottom, we would get the fourth root of 5 to the fourth. Root cancels out power, so 5. That's our answer, because nothing more simplifies. You got it! Yay! So good. Okay, let's look at another one, number 48, and then there'll be one more you can do on your own. Okay, 48. So look, none of my radicals simplify right here. If I tried to pull stuff out, I couldn't. But the problem is, once again, the radical on bottom. So with this one, once again, we would want to say instead of 9, 9 is 3 times 3. So rationalizing, we're going to multiply by the cube root of 3, right? Because now we'll have 3 of them. We already had 2. We needed 1 more to make it 3. Okay. So if you do that to the bottom, you've got to do it to the top. So we're multiplying by the cube root of 3. Now here's where people usually mess up. They don't realize that there's 2 terms. You're doing this times the entire top. So you've got to use parentheses so you don't forget to distribute. So now we'll distribute this out. This times 1 is, negative 1 times the cube root of 3 is negative cube root of 3. Cube root of 3 times cube root of 3 is positive cube roots of 9, right? And then on bottom now we have, I'm going to write it right here, the cube root of 3 times 3 times 3, which would be 3 cubed. Root cancels out with power, so on bottom we have a 3. We cannot add these because look, the base isn't the same. So we're done. We can't divide anything that's under a radical with what's not. Okay, there's one more for you to do. Do that one. Ready, go. Do 49, and then have me check it off, and then I'll come pick that up to hand in just a second. 5-2. It says simplify each expression. So everybody, this is just more review of what we've already learned, but more advanced. I'll come pick those up if you want to just stay. Yep, I'll come pick those up. Okay, here we go. So, on number 1, remember rational exponents are equal to a radical. If it says simplify, to me, simplifying a radical is easier to think about. So isn't this the same thing as the cube root of 125, which is 5? Well, then rational exponents in this was not as easy as a radical, so that's why I rewrote it as a radical. Okay, let's look at number 4. There's 2 ways to do this one. First of all, when you multiply the same base, you add your exponents. That's one way to do it. 1/2 plus 1/2 is 1. So isn't this 7 to the 1? Or way number 2, you could look at this as the square root of 7 times the square root of 7, which is the square root of 49, which is 7. Just depends on how you want to look at it. Okay, let's go to 11. Now in number 11, notice the bases aren't the same, so we couldn't do it when you multiply, you add thing, because they're not the same base. So let's instead look at this as radicals. We have the cube root of 12 times the cube root of 45 times the cube root of 50. Well, are they all under a cube root? Then we can put it under the same root. Well, we're not even going to multiply these out. We're not going to even get that big number, because why put it together as a big number when we'll then just split it back apart, right? So do you see how I'm leaving them separated, and now I'm going to break them down? 12 breaks down into 4 times 3. 4 breaks down into 2 times 2. 45 is 5 and 9. 3 and 3. With all that stuff going on, it would be easy to double dip, so I highly recommend going and crossing out what you've written as something else. So 4 is not there, 9 is not there, 10 is not there. Now I'm not going to double dip as likely. It's groups of 3. 3 of them, they can leave the house. Okay, good point. Yep, they all left the house. 3 times 5 times 2, and the radical's gone now. 30. There's our answer. Yeah, it's the same thing. We're just not doing that. I mean, it's the same thing. Yes. It's just how do you want to get there? You know what I mean? Okay, continuing. Look at number 5. This is the easy way of this one, in my opinion. Same base, same base, same base. True? When you multiply the same base, you add your exponents. A third plus a third plus a third is 3/3, which is, so we have -5 to the 1, which is -5. Same base, I just use properties of exponents, if it's the same base, that is. All right, do 1 through 12, quick, fast, and in a jiffy. Okay, this says we've got to read the instructions so we don't do extra stuff. It says write this in radical form. So remember, rational exponents are radicals, right? And radicals are rational exponents. I'll put a base on that. Right? Those are equal, correct? So looking at this, it says, rewrite each expression in radical form. Well, a decimal is not a fraction, so let's fix it. Take your calculator, type in -1.6, then you have to hit enter, then hit math, enter, enter. So this is really a to the -8/5. Okay, now we can rewrite it as a radical, but first we need to take care of the negative exponent. We know we take care of that by flipping our base over a fraction, right? So we would have a 1 on top and on bottom a to the positive 8/5. Now we've got to rewrite it as a radical. So what's my root? Yep, good. The 5th root of a, what the heck? The 5th root of a to the what power? 8. We don't need to simplify it, just says rewrite it in radical form. We've achieved the goal. Okay. Do 13 through 30, switch back and forth. One of them is asking you to go to radical form, and one of them is asking you to put it back as a rational exponent. It says rewrite the cube root of 2y squared in radical form. Yep. Okay, so question, is y and 2 both squared? Only y is squared. So you've got to make sure that your parentheses do not say that 2 is squared, correct? Well, then, aren't they both under a cube root? Then there has to be parentheses somewhere to say that they're both under a cube root. What exponent is going to go on top that won't change these two things? 1. Remember how we did that last time? Okay. Which one did you say was throwing you off? So, but why? Remember we talked about that parentheses can be written out here or in here. Same thing. What's the power? What's the root? 4. So no different. Parentheses doesn't change, so what the power is, what the root is. Does that make sense? Okay, cool. Okay, let's move on just to this section here where it says, actually go ahead and simplify this. So everybody look at 32. We're simplifying all the way. Now you can use radicals or rational exponents now that we know that they are equal. It's just which one's easier, really. So look at this one. We have base 81 raised to a power to a power. Raise a power to a power and you multiply the powers. A 4 times 4 is 1, correct? So our answer is 81 to the 1, which is 81. Which, couldn't we have thought of that as the 4th root of 81 to the 4th? Doesn't root cancel out with power? 81, it's just how do you want to look at it? Does that make sense? Okay, let's look at 38. When you multiply the same base, you add your exponents. So you would do a half plus a third. 5, 6. General rule of thumb, if you start with rational exponents, end with rational exponents. Okay, let's look at 39. This is all multiplication. Do not call this, oh, there's no exponent there. Yes, there's a 1 there. When you multiply, you add. So we have 2y to the 3/2. Okay, 47. These are basic properties of exponents. So we are looking at this. Isn't all this stuff raised to the 2nd power? Even 3? 3 squared is 9. We would make sure to not do 3 times 2, because that's not how it works. It's 9. Raise the power to a power and you multiply. A half times 2 is 1. 1/3 times 2. Nope. Let's go back to basics, everybody. 1/3 times 2 is the same thing as 1/3 times 2 over 1. Don't we multiply straight across? 2/3. And done. Questions? You're not the only one that thinks that. That's why I went over it. Okay, look at 52. Okay, first of all, with 52, isn't it true that when simplifying, we've simplified stuff of this caliber. Wouldn't it be best to see if we can simplify inside first? Well, x and y definitely don't simplify, but I would take 12 divided by 75 and then hit math, enter, enter, just in case. 4 over 25. Okay, that's going to be better to simplify because at least it's one step simplified. And then that's raised to the 1/2 power, correct? Now look, we could take and do 1/2, 1/2, all that, but why do we like the idea of radicals? Because radicals are easier to think about. So isn't this the same thing as a square root? So instead of doing it like that, let's just go like this. So now we can split it up. We have the square root of 4x to the 8th on top. We have the square root of 25y to the 10th on bottom. Now look how easy this is going to be. Square root of 4x to the 8th is 8 divided by 2. And then square root of 25. 5. 10 divided by 2. Yep. 5y to the 5th. Okay. Do that section. 32 through 52. Continuing. So on number 1, they're both square roots, so we can put them under the same square root. That's 4 times 25. Now, obviously, you could say that's 100, but let's just keep it apart. Just to keep our lives easier. Technically, it's easier to think of it as 100, right? Pull out a 5, pull out a 2, it's 10. Square root of 100 is 10, so it's making sense. All right, number 3. So looking at this, it's not the same radical, and it's not the same base. So technically, we maybe can, maybe can't. Now here's the trick. Doesn't this simplify? That is 3. Now look, 3 times the square root of 3 is literally 3 root 3, correct? Okay, next one. Okay, look at number 7. In the instructions, it says, you guys are all ruining my video. Okay, here we go. So it says simplify, and even though guys, seriously, don't talk when I'm teaching. I can't think. So, you had all of lunch. Okay, I'm going to add in, use absolute values when needed for extra practice on just this section. Okay, here we go. Number 7, square root of 36, 6, and then square root of x cubed. If you need to go back to basics and do this, that's fine for the first one. Isn't this what we're looking at? 6x square root of x. Now here's how you really, though, I don't want to see you doing that every time. I want you to start thinking more advancedly. You'd say, there's one group of 2, and then remaining would be 1. Okay, now look, even root, odd exponent, yes, so we would need absolute values here. I'm drawing them huge so that people don't think they're 1s. So I'm over-exaggerating them. Okay, let's go on to cube root. This is 25 times 5. This breaks down into 5 times 5. We're pulling out groups of 3. So we'll pull out a 5. Now I'm going to give myself some room, cube roots. Okay, y squared can't pull out since there needs to be 3. And then z to the 4th. How many groups of 3 are there? 1. So we pull out z to the 1, correct? Technically, though, we pulled out 3 z's. So how many is remaining? 1 z. Even root? No, so we don't need absolute values. I'm going to be going quick, so let's continue upward and onward. Continuing. 17 also, in this section also, I'm going to have you do absolute values just for practice. Okay. Multiplying these, we can put together because they're both square roots. So this is 9 times 9. I'm going to put like things by each other. Then I have an x squared and a y to the 5th. Right? Now I can simplify. So, pull out a 9, don't we? Pull out a square root of x squared. And then how many groups of 2 are there in 2? Good, in y to the 5th. So you did 5 divided by 2 and you got 2.5. So at least it came out evenly 2 times, y squared. So then left under our square root, if we pulled out 2 groups of 2, we would have pulled out y to, like 4 y's, correct? Remaining is y to the 1. Yes. Good question. So even root, odd exponent right here. So we would need absolute values around x only. Okay, let's do 18. So you look at this one and you'd say, okay, they're both cube roots, so let's put them under the same cube root. We have a 50 times 15. I'm going to leave them apart because I'm going to break them apart anyways. I have an x squared, no other x's. I have a z to the 5th and a z, so that'll be z to the 6th. And then it looks like I have a y cubed. Now we're pulling out groups of 3. Let's break these down. Okay, so when I pull out a 5, and then left, oh, I gotta give myself some room to write, because we are probably gonna pull out more than just 5. Okay, 5, and then leaving myself some room. Make sure you tuck the 3 in there. Do you see how gorgeously I write this? You all need to do that. Cube roots of, so I pulled out my 5s. Then left was a 2 times a 3. 6. Okay, moving on, x squared. We don't have 3 of them, so it's got to stay under my radical. 6 divided by 3. 2 evenly. So z squared. 3 divided by 3 is 1. So this would be our final answer. Even root? Nope. So we don't need absolute values. All good? Okay, 24. So look, this is all times signs. Because it's just multiplication, we can reorder it in any order. 7 times 2 is, so on the outside we technically add a 14. Now underneath I have a 3 of 6, which is 3 times 6. I'm going to leave it apart. Y squared times y, won't that be y cubed? And then we still have an x cubed. Now, looking at this, we'll continue to simplify. So 6 breaks down into 3 times 2. And since it's a square root, we're pulling out groups of 2, correct? Okay, so 14 times 3. 42. Okay, and then look, under our square root is a 2 left so far. Now y cubed, we're pulling out groups of 2. So when I pull out a y, how many is remaining? 1y. Pull out a x, how many is remaining? Perfect. Even root? Yes. Odd exponent here. Odd exponent here. Yep. So you need absolute values around both. So hopefully, once again, this is not new to us. It's just now a little bit more advanced than last time. Yeah. Just remember that you're pulling out an x for those 2 x's. We're pulling out groups of 2. Okay, do 1 through 24 on that page. I'm going to give you some time to do that. There are times when we won't have to. So look, this is really important to understand though. There is a difference between this and problem 25. So look, in this example, 75 is not under a radical. We have no choice but to rationalize the denominator because we can't simplify 75 and 3. Root 3, that is. Everybody understand? So the only way would be to say I need to multiply by root 3 over root 3, 75 root 3 over 9, and then if those simplify, we could. Okay? But right here, we could do this the hard way and rationalize right now. But instead, because they're both under square roots, we should first put them together and simplify everything possible. So look, because they're both under a square root, that's the same thing as going like this, isn't it? We split things apart. Let's put them back together. Now, what is 75 divided by 3? So we're really just looking at the square root of 25, which is 5. That was a lot easier than rationalizing and simplifying my answer to get 5. We would have done it. We would have still got it. It just would have taken 10 times longer. Awesome, right? Okay, look at number 28. So once again, the first thing you should do from here on out is look and see if you can simplify the top with the bottom, which we can, correct? Let's do that first. So we have the square root of 6x divided by 3x. Now what's important is to put it in the right spot. Does it simplify on top or bottom? So what does this become? 2. Square root of 2, and 2 was on top. That's my answer. Does it simplify? Nope, so we're done. Okay, next one, 29. A lot of people will just rationalize. But once again, from here on out, rewrite it, simplify first, and then if you need to, then rationalize. So what does this become? The cube root of 4x on top, correct? Now look, nothing simplifies. So once again, we're done, because we can't pull out any groups of 3. So we have not even had to rationalize the denominator yet. Yes. We could have done it the long way and done the cube root of x squared, the cube root of x squared, and then on top we would have had the cube root of 4x to the 4th, wouldn't we? And then on bottom we would have the cube root of x cubed. Doesn't root cancel out power? And then we could have pulled out this and we would have ended up right here. So do you see how much harder that was? So what we'd want to do first is put them together and simplify, and then, if need be, rationalize only then. Okay, another one. Look at 31. Now this one doesn't simplify, and even if it did, you'd have to be careful because this is squared. So let's just worry about simplifying it in sections. So up here, isn't that really the square root of 4x squared? 2 squared x squared. And then on bottom, aren't we dealing with the square root? It's to the 4th, and so that's the square root of 625, because 5 to the 4th is 625. And then y to the 4th. Well, now we can simplify. So, what's the square root of 4x squared? 2x, and on bottom, square root of 625 is 25. And then the square root of y to the 4th. Y squared. So everything came out of the radical, am I right? So no more radicals. Okay, there is one more I want to do. So everything I just showed you, we didn't have to rationalize the denominator, but that won't always happen. So let's look at 32 real quick. We have the cube root of 18y squared over the cube root of 12y. Now understand, still it is a better option to put it together and simplify as much as possible first. So this is the cube root, 18 and y squared on top, and on bottom we have a 12 and a y. Let's simplify first, but now make sure you really keep track. I have not taken any cube roots yet. So 18 divided by 12 in your calculator, do it, and you would hit math, enter, enter, and we get 3 over 2. Make sure you place things in the correct spot. Now you have a y squared on top and a y on bottom. So where's my y going to go? On top. Okay, good. Now look at our answer. That is a great answer, but it's not considered simplified. Why? Because doesn't it still have a radical on bottom? But still, isn't this prettier to rationalize than before? Yes. So let's split this back apart. So we have the cube root of 3y over the cube root of 2, because nothing more simplified. So now we split it back apart and we rationalize. So even though it's simplified, we still have to rationalize. But at least that's a lot easier to rationalize than, once again, that. You get what I'm saying? Can't help. Okay, cool. Let's continue. So how many more 2's do I need? Good. 2 more. Cube root of 2 times 2. So now on top, I have a 3, a y, a 2, and a 2. So that would be 12. The cube root of 12y. And then on bottom, won't I have the cube root of 2 cubed on bottom. So root cancels out with power and we get a 2 on bottom. There's our final answer. Okay, do some in that section. 25 to 33. Do some rationalization. On 34, look at the problem. Does anything simplify even if we put it together? No, so we've got to say, that's my answer, it's just not acceptable. We're going to have to rationalize, right? Root 5. So on top, when we have root 5y, and on bottom we'll have a 5. Okay, look at number 35. Don't you think we should put them together and simplify first? Okay, let's quickly do that. We have our 18x squared y on top, and on bottom we have a 2y cubed. Make sure you put things in the correct spot. We have the square root. 18 divides by 2 and becomes 9 on top. X squared is still on top, isn't it? Now, shouldn't I have a y squared on bottom? Now from there, you should split it apart. We have the square root of 9x squared on top, and on bottom, the square root of y squared. Simplify if possible, and if it doesn't, then we would rationalize. Look at the top. What is the square root of 9x squared? Then on bottom, we have a y, and that's my answer. Do we still have a problem with the radical on bottom? No, because it's simplified out. Okay, look at 37. Does anything simplify? 9 and 2 don't simplify. But what you mean is we're going to split this up. And then what you were saying was, okay, we have a radical on bottom, we've got to fix that, but 9 does pull out, correct? So we're really dealing with 3 root x on top, square root of minus 3. Now on bottom, we're dealing with root 2. Is that a final acceptable answer? No, we still have to rationalize. We multiply by root 2. So on top, I'll have 3 square roots of 2x, and on bottom I'll have 2. $38. Do you think simplify? The x's. So what's left on top? Root y. What's left on bottom? Root 3. Is that an acceptable final answer? Nope. We've got to hurry and rationalize the denominator. So on top we have the square root of 3y, and on bottom we have a 3. You're awesome. Okay, look at 42 with me. This one's the hardest one for people to rationalize just because it's different. So look at 42. Nothing simplifies with the top and bottom. So that would mean we would split it up. So this is the cube root of 3a over the cube root of 4b squared c. Now look, none of those radicals simplify, do they? No. So we've got to rationalize. Now I would rewrite that denominator as, instead of 4, what is it? 2 times 2, and then we have our b times b, don't we? And a c. Because we want to rationalize by the least amount possible. This is our original problem. We've just rewritten it in a format where it's easier to rationalize. Okay, cube root. We have 2 2's. How many do we need? 3. So how many more do I need? 1 more. We have 2 b's. We need 3 of them. 1 more b, right? Okay, then we have 1 c. How many more c's do we need? 2 more. Okay, let's do it to the top then. The cube root of 2 times b times c times c. So now look, this was under a cube root, and this is under a cube root. So let's put it all under the same cube root. 3 times 2 is 6. That doesn't simplify. We have an a b, and a c squared. None of those simplify. If they did, we would need to do that. Now on bottom, technically, I'm going to go write it off to the side. On bottom, we have the cube root of 2 cubed, b cubed, c cubed, don't we? We created that on purpose so that root would cancel out with power. So on bottom, we have a 2bc, 2 times b times c. We can divide stuff that's under a radical with something that's not. Are we doing okay? Okay, Okay, do some in this section. To be caught up with the other class. Flip to the next page. Number 1, this is all just review, and these are the very basics. So this is where we're going to end, pretty much. Okay, 9 root 3 plus 2 root 3s is how many root 3s? 11 root 3s. Very good. Number 2, 5 root 2s plus 2 root 3s. Can we even add them? The apple isn't the same, so no. So literally, that's our answer. You can't add them. That's our answer. Just put a check mark. That's our answer. Okay, look at number 4. 14 cube roots of xy minus 3 cube roots of xy is how many cube roots of xy? 11 cube roots of xy. The apple doesn't change. Let's look here. 6 root 2 minus 5 cube roots of 2. Can we do it? No. The root and underneath has to be the same for addition and subtraction. So that's our answer. You can't put them together. Yes. So you will finish up 1 through 9. And then also, look at number 14, one example. This is what we learned last time. And then I'll tell you where to stop on your homework. We would need to break this down. 75 is 25 times 3. This is 5 times 5. So I pull out a 5. Isn't there already a 3? 15 root 3. Then right here, we would say 4 times 3, 2 times 2. So we have plus 4 root 3s. Well, look at that. They're like radicals. 15 plus 4 is 19 root 3s. So just a reminder of how to do those. So this is what you need to do as homework. The first and second page, front and back, it says right down there, page 1, page 2. And then you need to do on page 3, 1 through 18. And you can stop there. Don't cross out the other stuff. You're right.